everyone. Problem 8.2a. Alright, so part A of 8.2a. 8.2a. This is part A. It says, well, in 8.2, we have an invention that makes everyone can sleep by 10 hours fewer per week, providing an increase in their weekly leisure endowment. So everybody gets 10 more hours. For each of the cases below, can you tell whether a worker will work more or less? Alright, and the first one is the worker's tastes over consumption and leisure are quasi-linear in leisure. Let's draw this out, okay? So, down here, we'll have leisure. Over here, we'll have consumption. Originally, we have some point, and I am consuming at point A, right? So I'm consuming this much consumption and this much leisure. This is my cap L leisure endowment. So the amount that I'm working is from this portion to this portion here. That's the amount that I dedicate to work. Now, suddenly, there is an increase in the amount of time I have because I get to sleep less. So let's see how that's going to look. Well, it doesn't change the opportunity cost or the slope. Really all it does is it gives me 10 more hours of my life. So now I'm right here, I'm at L plus 10, okay? And so it looks a lot like an increase in income for the consumer problem when there's an X1 and X2. And really, it proceeds the exact same way. So we know that in part A, the worker's taste over consumption and leisure are quasi-linear in leisure. Well, quasi-linear in leisure means there's no income effect or wealth effect, so that means that the point here for little a, for part little a, is going to be straight up there. Now, does the worker work more or less? This is not too hard to figure out. Though, don't forget that from here to here is my, let me draw this here. From here to here is my leisure. From here to here is my labor, how much I work. Now, if I get more hours and I have a quasi-linear in leisure, that means I work straight up, there is no income effect. That means now my new work hours are from here to here, you see? So they have increased when they're quasi-linear in leisure. Alright, next question is the worker's taste over consumption and leisure are homothetic. So what does homothetic mean? Well, homothetic means the answer, or the optimal bundle, will lie on a ray from the origin. So, for little part B, it will lie right there. Now, I want to say, we're going to say, hey, is the distance from here to here, which is how much we were working before, now we're working from here to here, did that change? Well, in order to do that, we're going to have to add another point. I'm going to call this point, if I go straight out, what happened here? I added 10 hours of my life, right? Now, what happens if I just add 10 hours to leisure all the way to here? I get this point right here. I'll call that point F for right now. Okay, point F. And that is the point where I am working the exact same number of hours as before, right? So the difference from here to here, the labor hours, is the same as here to here. Okay, now that we have F on here, it's much easier to see what happens when preferences are quasi-linear. As you can see, the distance from here to here and here to here, that would be the same amount of labor, but we're actually going from here to B, which is there, so that's an increase in labor. So the individual does use some of their hours for labor, meaning they work more, and they use some of their hours for leisure, meaning they also leisure more. But the question asks if they work more. All right? Part C asks if leisure is a luxury good. So what does that mean? If leisure is a luxury good, that means that the point, my new point, could be anywhere to the right of the homothetic ray, right? Well, look, F is kind of our break-even point. If my point ends up here somewhere, yes, I will labor more. If my point ends up here somewhere, no, I will labor less. So, just knowing that leisure is a luxury does not tell us whether or not we're going to work more, labor more, when I get 10 more hours. Okay? Here we have in part E, it says the worker's tastes over consumption and leisure are quasi-linear in consumption. So quasi-linear in consumption means that I'm going to stay on this vertical line even when I increase. So I'm actually, when they're quasi-linear in consumption, I'm going to consume no more and I'm going to work exactly, or I'm going to leisure exactly 10 hours more. I will be at this point F. That point F is the point where I worked exactly the same amount as before. And so the answer to this is if we're quasi-linear in consumption, then if I get 10 more hours, since I don't consume more, I don't have to work more, I use all of my additional 10 hours towards leisuring. Okay, so the answer to part E is that I end up at this point here, point F, and I work the same amount as before. Finally, it asks, do any of your answers have anything to do with how substitutable consumption and leisure are? Why or why not? You see that this has nothing to do with how curvy the indifference curve is. That's the amount of substitutability. No matter if we have perfect complements, perfect substitutes, Cobb-Douglas, somewhere in the middle, we're always going to have the exact same movements. Alright, hey guys. 8.2b. So we have a utility function that looks something like this. U is equals c to the alpha, leisure to the 1 minus alpha. Just a brief note, I'm not using the curly L for leisure because I always use that for labor. I'm using the italic L for leisure, even though that's different than what's going on in the end of the book here. Okay. Part A says write down the worker's constraint optimization problem and the Lagrange function. Okay, so really the problem is, well actually I'll just use this. We want to maximize, they can choose consumption and leisure. We want to maximize the objective function subject to a budget constraint. And the budget constraint is always that they can consume as much as they're making. So it's wage times how much are they working, cap L minus leisure, where cap L is their leisure endowment, minus L is how much they leisure, this is how much they labor, times their wage is how much they can eat. Alright, if I go ahead and write down the Lagrange function, so the Lagrange function is that we take the objective function and we add lambda times the constraint with everything moved over onto one side. I'm going to go ahead and move the C over onto this side. I'm also going to multiply this out to make it a little easier. WL minus W leisure minus C. That whole thing's equals 0. Okay, so that's the Lagrange. Now, in part B, it says solve the problem to determine leisure consumption. So basically, at the end of the day, we want to solve for L, leisure. I can solve it using the Lagrange, and if you want to, go ahead. I'm going to, however, use the shortcut because otherwise it will take me a really long time to do this. Remember, the shortcut in general says MRS equals P1 over P2. In this world, let's just think for a little second here. We have leisure, instead of X1 we have leisure, and instead of X2 we have consumption. So what is the price of leisure, P1? Well, that's wage. And what is the price of the composite good consumption? Well, that's 1. So really, this is going to turn into, in this case, something, the MRS is equal to wage over 1. And what's the MRS going to be? Well, normally the MRS is partial U, partial X1. But in this case, X1 is being taken up by leisure. So it's going to be partial U, partial leisure, divided by partial U with respect to consumption. Okay, now let's go ahead and find that. So, partial U with respect to leisure, well, let's go ahead and take it with respect to leisure. So I bring this down, it's going to be 1 minus alpha. Consumption to the alpha, leisure to the 1 minus alpha, minus 1, that's just going to be negative alpha. Alright, and now partial U with respect to C, we'll do the same thing here. We have an alpha, bring it down, C to the alpha minus 1, leisure to the 1 minus alpha. And that's all equal to wage. Okay, let's simplify this. This implies that, I'm going to pull these out in front. So I've got 1 minus alpha over alpha. All right, notice the leisure is a negative alpha. If I bring it down, it becomes a positive alpha. So I'll have leisure to the alpha and leisure to the 1 minus alpha here. So we add those together. We'll have alpha plus 1 minus alpha. The alphas cancel. And we just have a leisure on the bottom. Same thing here. Notice alpha is between 0 and 1. So alpha minus 1 is actually negative. Let's bring it up top. When I bring alpha minus 1 up to the top, it changes the sign. So it's actually going to be negative alpha plus 1. So I'll have a c to the alpha. And this guy I have a c to the negative alpha plus 1. So I have alpha minus alpha plus 1. The alphas cancel. And I just have a c right here. And this is equal to w. This is one of those moments where you stop and you try to remember, what are we solving for? At the end of the day, I want to solve for leisure. However, looking at this here, I can see that I'm in the case where I have 2 endogenous variables and only 1 equation. So I'm going to have to end up plugging it into another equation, so I get 2 equations, 2 unknowns. The equation I'm going to plug it into is a budget constraint. I want to plug in this solved out for c into the budget constraint, so that when I do that, I just have leisure. Okay, so let's solve this guy out for c. And that's not too difficult. This implies that c is equal to, all right, so I have a w over there. I multiply the leisure to both sides, and I multiply by the reciprocal in order to get rid of that. So I've got alpha over 1 minus alpha. All right, so I have alpha, consumption is equal to alpha over 1 minus alpha WL. Plug this into the budget constraint, so I plug, for c, I plug this guy into this right here. Plug into budget constraint. And what do I got? I got alpha over 1 minus alpha W leisure is equal to WL cap L minus leisure. I'm going to multiply that out. WL minus. Actually, no, I'm not. I'll just write it just like this. WL minus leisure. And the reason why is because I can see this, I can see the W's cancel. Okay? And, so now what do I have? My W's cancel. I can also, on this side is just cap L minus leisure. I want to solve for leisure, so I'm going to put all the leisures over here. I'm going to add a leisure to this side. So I will have leisure, that's the one I just added, plus alpha over 1 minus alpha times leisure, that's this, equals cap L. Okay, let's continue solving out for leisure. I need to get these guys together. I can factor out a leisure. So this implies that take the leisure I factored out, that will be times 1, and this will just be times alpha over 1 minus alpha equals cap L. Alright, so I have leisure times 1 plus alpha over 1 minus alpha equals cap L. I can divide both sides by this term. I should make it a little bit prettier here. I'm actually going to call this 1, I'm going to call, because I need to add something with a fraction, I'm going to call it 1 minus alpha over 1 minus alpha. Okay, so here we've got 1 minus alpha plus alpha all over 1 minus alpha. 1 minus alpha plus alpha is just 1. So that term right there is just 1 over, and then the common denominator is 1 minus alpha. Alright, I've made that a little pretty. It's being multiplied by leisure. It's equal to cap L. This implies that I need to divide both sides by 1 over 1 minus alpha, which is the same as multiplying both sides by 1 minus alpha. So I have leisure is equal to leisure times 1 minus alpha. Okay, this right here is all done. It's my endogenous leisure in terms of just exogenous variables. And it says, will an increase in L result in more or less leisure consumption? When L goes up, leisure consumption goes up also. Okay, and C says, can you determine whether an increase in leisure will cause the worker to work more? Well, let's go ahead and calculate some labor. Labor is equal to cap L, the total number of hours I have, minus my leisure. Well, I know what my leisure is, it's this right here. So this implies that labor is equal to L minus L times 1 minus alpha. Okay, if you can look at this, let's multiply this out. Negative L times 1 is negative L. And L times negative alpha is negative L alpha times the negative. So actually, this is going to be L minus L plus alpha. L minus L's cancel. And I'm left with, oops. Labor is equal to L alpha. So if I get more leisure endowment, then yes, I will labor more also. Of the leisure, if you give me more hours, alpha percent of them I'll work, 1 minus alpha percent of them I will consume, I will leisure. It makes perfect sense considering that's what these told us right here. Alright, finally, we're going to repeat the above parts using the utility function consumption plus alpha natural log of leisure instead. So let's just do that real quickly. Okay, I have consumption plus alpha natural log of leisure. I'm going to use the same trick, the MRS, which is partial U with respect to leisure divided by partial U with respect to C. So let's do that. Partial U with respect to leisure divided by partial U with respect to C was equal to W. So this implies that, and this is setting it equal to 0 for equal to each other for the purposes of the shortcut. Let's do partial U, partial L. The derivative of this with respect to L is 0. The derivative of this with respect to the leisure is alpha over leisure. Divided by, what's the derivative with respect to C? Well, that's 1 and that's 0, so it's just 1 equal to wage. Implies that wage is equal to alpha over leisure. What are we solving for? We're solving for leisure. This implies that leisure is equal to alpha over W. Okay, and let's go ahead and find labor. Labor is equal to cap L minus leisure, which implies that labor is equal to cap L minus alpha over W. So now we're going to answer those questions. What happens if you give me more L? Here, my leisure does not increase. Hey, that should make sense. You should be able to look at this and say, hey, that's quasi-linear in leisure. If I get more of my endowment, I'm not going to buy any more leisure. That's what that says there. What do I do with my whole entire increase in L? If L goes up, that makes my labor go up. All of my additional hours of potential leisure are consumed working. Okay? And that's the only parts that I have you guys doing.